on probability. And here, if we have events that have uncertain results, that we call them experiments, and the possible results are called outcomes. And we have all the possible outcomes is called the sample space. And then the subcollection of the sample space we call an event. So we're going to look at a number of examples on probability. So we'll take our first one here. We roll one die. And what's the sample space? Well, that's all the possible outcomes. We could get a 1 or a 2 or a 3, 4, 5, or a 6. So that's the sample space. What about when two coins are flipped? What's your sample space? Well, they could both be heads, or it could be a head and a tail, or it could be a tail and a head, or it could be a tail and a tail. Then the last one, we have a coin and a die tossed. What's the sample space then? Well, it could be a head and a 1, a head and a 2, so on and so forth to head and 6. And then we could have a tail and 1, a tail and 2, so on and so forth, up to a tail and 6. So there's 12 possible outcomes. So when we talk about probability, we say probability of an event is P of E, and it's defined as the number of equally likely outcomes divided by the total number of outcomes in the sample space. So let's look at what happens when we flip a coin. What's the probability of a tail? Well, we could get the likely outcome, 1 tail, out of the total sample space, which would be 1 tail plus 1 head. So actually I have it here. And so it's 1 over 2, or 50%. Now probabilities can either be expressed in fractions or percentages. Usually fractions is preferable, but not always. All right, let's look at our next example. You flip 2 coins. What's the probability that they are both heads? So the probability of a head and a head right here. So how do you get that? Well, it's a head and a head would be the outcome, and then you have 4 ways to flip the coin, so that would be the probability of both heads would be 1/4. All right, next example, what's the probability of drawing a heart from a deck of cards? Well, the outcomes are there's 13 hearts in a deck, and the deck has a total of 52 cards. So 13 out of 52 is 1/4. The next example, what's the probability of rolling a 7 in the game of craps? Well, craps use 2 dice, and so the dice, and they're labeled 1 through 6 on each die, and so the sample space, or the total amount, is 6 times 6, because each one can roll a 1 through 6, and that's going to be equal to 36. So now we need to look at the possible outcomes of rolling 2 dice. So that would be N E. This is N of S. And so 2 dice, you can roll a 1 and a 6 to get 7, or you can roll a 2 and a 5, or a 3 and a 4, or a 4 and a 3, or a 5 and a 2, and 6 and a 1. So there are 6 ways to roll a 7, a total of a 7. And so now you have a 6 over 36. So the probability of rolling a 7 is 1/6. Looking at the next example, what's the probability of rolling a sum of 4 with 2 dice? So the outcomes rolling a 4, you could roll, let's make that, yeah, we'll stick with a 4. How do we roll a 4? We can roll 1 and a 3. We can roll a 2 and a 2, or a 3 and a 1. So we have possible outcomes equals 3 ways. And we already figured out that n of s is 36. So this is 1/12. Okay, the next example is a little bit different. So we have a class that is given 20 sample problems to study for a test, and 10 of those problems will be on the test. So if a student can solve 17 out of 20, what's the probability that they will get all 20 problems correct on the test? Well, so the probability of the event, which is n of e over n of s. Now, n of e is going to be the number of combos, or the combinations of getting 10 out of 17. So we write that as a combination, 17C10. And n of s is the number of combos getting 10 out of 20. So this would be 20C10. You put that in your calculator, you get 2 over 19. So roughly, well, it's exactly 10.5% probability of getting all 10 right if you only know how to solve 17 out of the 20. Okay, let's look at mutually exclusive events. This means that event A and event B do not have any outcomes in common. And so the individual probabilities are added to each other. So let's look at an example. If you pick one card from a deck, and remember the deck has 52 cards, what's the probability of picking an ace or a club? And when you see or in it, that means and. So you're going to add the probabilities because these are mutually exclusive. Okay, so the probability of an ace, well, there's 4 aces in 52 cards, so that's 4 out of 52. And the probability of a club, well, there's 13 clubs in 52. But then you have to take into consideration that the card you pick is actually the ace of clubs. And the probability of a ace of clubs, that's only 1 in 52. So the probability is equal to the probability of an ace, which is 4 in 52, plus probability of a club, which is 13 in 52. But then you have to subtract out the probability of ace and a club because it's included in either this group or this group. So minus 1 out of 52. And so that turns out to be 4 out of 13. All right, the next example, the student population of the school is as follows. So from 7th to 12th grade, these are the percentages in the school. If you were given the numbers of students, you would have to calculate the percentages. But here we're just given the percent. So what's the probability of a 9th grader that is picked? So you have the entire school and you pick one person out of the entire school. What's the probability it's going to be a 9th grader? Well, that's just the probability of being a 9th grader. So that's equal to 27%. What's the probability of a 7th or an 8th grader being picked? Well, the or means and so you're adding these. So the probability of the 7th is 16%, and the probability of an 8th grader is 25%. So that just gives you 41%. All right, let's look at one more. What's the probability of not a 12th grade? Well, you could add up all of the probabilities of the 7 through 11, or the easier way is just 1 minus the probability of it is a 12th grader. So it's 1 minus 3%, so that gives you 97% probability it's not a 12th grader. Okay, the next thing we'll look at is independent events. This is defined as the event A has no effect on event B. So in other words, you're trying to find the probability of A and B. It's the probability of A times the probability of B. So let's look at our first example. We have two numbers, 1 through 30 are picked with replacement. So what that means is, say if you have 30 numbers in a bag and you pick one and then you put it back, and so you still have 30 numbers to pick for the second time around. So we want to find the probability that both numbers that are picked are less than 12. Well, how many numbers are there less than 12? There's 11. So it's 11 out of 30 for the first pick, and it's the same thing for the second pick, 11 out of 30. So you're multiplying these, and so this turns out to be 121 over 900. So that's the probability that they are both less than 12. All right, what about the probability of flipping a coin 5 times and getting all heads? Well, the probability of getting a head is 1/2 for the first time, and the second time it's 1/2, third time it's 1/2, fourth time it's 1/2, fifth time it's 1/2. So this is 1/2 to the 5th power, which is 1 over 32. So the probability, this turns out to be roughly 3%. So you have about a 3% probability of flipping 5 heads in a row or 5 tails in a row. Okay, the next one, it's given the probability of dropping first semester calculus in college is 70% if you didn't take calculus in high school. And the probability of getting an A in first semester college is 25%. So what's the probability of getting an A in the first semester of college calculus if you didn't take calculus in high school? So the probability of dropping is 30 or 70%. So that means the probability of not dropping is 1 minus 70%, or 30% probability of not dropping. And if you don't drop, you have a 25% probability of getting an A. So this turns out to be 3 out of 40, or about 7.5% probability of getting an A in first semester calculus in college if you didn't take calculus before. All right, the last example is kind of an interesting problem, is what's the probability of 2 people in a class of 36 being born on the same day of the year? Doesn't have to mean the same year, but just the same day of the year. And if you ask most people this, they go, well, 36 out of 365, probably about 10%. But this is the formula you used to find this probability, and it turns out it's nowhere near 10%. So we have 365 days in the year, that's N, and R is going to be our class size of 36. Now, this doesn't have to be a class. This can just be any group of people numbering 36 total people. And so you put it into the formula. We have 1 minus 365 P36 divided by 365 to the 36. And the reason, so just this here, this part is going to give you the probability that 2 people don't have or weren't born on the same day, any 2 people. So we subtract it from 1 to give us the probability that they were. So 1 minus 365 P36 divided by 365 to the 36 is 83.2%. 83.2% probability that 2 people out of 36, these are just random people, will have the same, were born on the same day of the year. So that's a pretty interesting statistic there. All right, so that's it for 9.7.